Let's start with tokenization. Tokenization is the first step in the NLP pipeline, part of the family of algorithms dealing with lexical analysis. Here, tokenization means splitting a string into a series of tokens, where we're going to say the set of all tokens forms a vocabulary. Now, tokens should be meaningful. They should carry what the representation of a token actually means. So typically, they're going to be words, numbers, or punctuation. But that can differ depending on application and the type of text that we're inputting. And like anything in lexical analysis, it's a very important step. Why? Because when we have errors, they're going to quickly propagate to all of the interesting NLP applications that we have downstream. So it's a case of garbage in, garbage out. Now, tokenization has three basic approaches. We can use a character-based approach, which we've already learned. We can use a regular expression that Chris has taught, which is just the period as a character class to get individual characters. For example, S, H, E here. But this won't have much semantic meaning, so this doesn't look very good. Rather, we might try to use subword-based or word-based methods. These are more detailed, so we're going to go into it in the next couple of slides. Let's first look at word-based approaches. Word-based approaches means that we have to have white space to delimit words. Otherwise, we have to figure it out on our own. More on that later. There are two intuitive approaches. We can first either match the content itself, so words, numbers, and punctuation marks. For example, here we might have /W plus for all of the green tokens here, punctuation marks in some small character class of commas, periods, semicolons, and colons, or numbers like we have over here. The other way to do it is to look for things that are not words and try to match those boundaries. So we have the case of a look ahead and a look behind for non-words or /W. Let's see how that might work. Here we have the same expression. NLP is fun and there is so much to learn in 13 weeks. Let's go ahead and write the expression that we saw in the first case. And we can see what's been matched. You can also write the other case, right, of the look ahead and look behind. Here we need a capital W to make sense. And you can see that it's matched all the boundaries between words. Tokenization gets pretty tricky quickly, and this is because we have a lot of different things, even in something as simple as English as a language, for tokenization to get clobbered on. One is for multi-word expressions. So here we have New York City, but this phrase means something different than New York and City as separate words. Here we have don't as two separate tokens, Dawn and T, and same with I and M over here, which looks wrong. Hyphenations are another case. Should well-defined be a single token, and same with non-trivial, or should they be two separate tokens each? And how about acronyms or names? C++ here is a single token, but it doesn't get captured with our particular regex use, where it misses plus signs. And similarly for the @ symbol in an email address. Here, even the emoticon is only partially captured, missing out the parentheses. So the challenge is that shapes and formats of tokens can vary significantly, and this means that we either have to use a very complex regular expression or come up with some type of alternative approach that might help us. And it can differ because the rules for tokenization might be different for different types of inputs. So you might want to try different tokenizers to see whether yield different results. Here's an actual example from the Spacy Tokenizer, a library that we've asked you to install. Spacy's tokenization first splits on white space characters, so it works for English in this case. So we can see white space, white space, white space here, splitting it up into 4 tokens as a start. Then, from left to right, in an iterative manner, we're going to go through all of the tokens. And for each token, we're going to recursively check the substrings to see whether a substring match matches an exception rules or whether we can lop off a prefix or suffix. Let's take a look at this. In the first step, we identify a prefix. So there is this open quotation mark let's, and this we can strip off a prefix of the double quotation mark. After we examine the double quotation mark, that looks fine as a token, but let's could be split. It's an exception rule, and therefore we get let and apostrophe s as 2 tokens. These 2 are okay, and iteratively we go down and see go and 2 are also fine. So these are all fines for now. When we get to ny exclamation mark quotation mark, there are 2 suffixes that can be split off. And then finally, we see n.y. as a case where it's an exception that doesn't need to be split any further. And then all of the remaining tokens are fine.